Hello, so in today's video, we're going to move on to a new topic. We're going to move on to partial fraction decomposition. So the aim of partial fractions is essentially an example like this that we can see on the screen here. So can we write a fraction like 2 over x plus 2 times x minus 3 in the form a over x plus 2 plus b over x minus 3? So can we write this fraction in a form where we can actually split up these factors on the denominator? So we've got two different fractions with those factors on each denominator. So can we do that? And the answer is actually yes, we can. So yeah, this is partial fraction decomposition number one. I'm just going to call this number one because there are a few partial fraction decompositions that we need to know for the course. So this is the first one that we're going to cover in today's video. So the fraction, so if you have a fraction in this form here, so a number times x plus a number divided by cx plus d times by ex plus f on the denominator, this can be written in the form like this. So this is always true. It can be written in the form a over cx plus d plus b over ex plus f. So this is the first partial fraction fact that you need to know, that this fraction here can be written like this, where all of these letters are all real numbers. So you can write it like this. The key thing to note as well is that the highest power of x on the top is 1. So we call this the degree. So the degree of the numerator, the numerator is equal to 1. It's called the degree. The degree is just basically the biggest power of x. So the biggest power of x we see there is 1. Now the biggest power of x on our denominator is actually going to be 2, because when we expand the brackets, we would get when we expand that, we get cex squared. So the degree here is 2. So the key thing to note with this partial fraction decomposition is it will only work if the degree of the numerator is less than the degree of a denominator. So that's just a key thing to note. I will come on to that again in a minute. And yeah, so like a further example then. So let's say again you've got a fraction like this, ax squared plus bx plus c divided by these three linear factors multiplied together on the bottom. This can be written like this. So again, you can split up this fraction into three different fractions. Again, the key point that we mentioned before, the degree of the numerator must be less than the degree of the denominator. So the degree of the numerator here is 2, because the biggest power of x here is 2. The biggest power of x of our denominator is 3. So the degree there is 3. So when we expand the brackets, we would get an x cubed term here. So the degree of the top is less than the degree of the bottom. So this works basically. If it was the same degree, if the degrees were the same, or the numerator had a bigger degree, you would actually just use normal long division for algebraic fractions. And we did that in a previous video, in one of my previous videos before, so you can check that video out if you would like to. So yeah, this again, if you've got a degree smaller on the top than the degree smaller on the bottom, you can use this composition here, this decomposition. So let's look at an example here. So the question is, can we write the fraction x minus 1 divided by x squared minus 4x minus 5 into partial fractions? So let's have a go at this example. So first and foremost, what we're going to have to do here is we're going to have to basically factorize our denominator. So we've got x minus 1 on the top. But can we factorize this into two linear factors? Yes, we can. We can put an x in there, an x in there. Factors of -5 that add up to -4. Well, that would be a -5 inside there and a +1 inside there. So we get a factorized form. So now we can put our linear factors on our two denominators here. So we're going to break it into partial fractions. Now the trick now is we've got to work out this a value and this b value. That's all we have to do in this case. So to do this, what we're going to do is going to multiply both sides. So multiply both sides by x minus 5 times by x plus 1. So multiply both sides by this denominator. And if we do that, we will get x minus 1. So yeah, with this equation here, multiply both sides by the denominator, we get x minus 1 is equal to a times by x minus 5 times by x plus 1 divided by x minus 5 plus b times x minus 5 times by x plus 1, and then divide that by x plus 1. Now, what you'll notice is that with this first one, the x minus 5 will cancel out there, and the x plus 1 will cancel out there, because x plus 1 with x plus 1 is just the number 1. Let's just make this all a bit smaller so we can fit this on the same page. So what we get then is we get that x minus 1 is equal to a times x plus 1 plus b times x minus 5. Okay, so we get that. Let's just expand the brackets. We get x minus 1 equals ax plus a plus bx minus 5 lots of b. Okay, now let's kind of factorize what we've got here. So we've got a plus b lots of x plus, sorry, let me try and write this again a little bit neater, plus a minus 5b is equal to this x minus 1. Okay, so what can we say from here? Well, just by looking at what we've got here on our left-hand side compared with our right-hand side, what can we say? Well, we can say that we've got a coefficient of x here of 1. So that must match with this coefficient of x here. Obviously, you've got an x there and an x there. So a plus b must be equal to 1. We can say that for a fact because 1x on the left-hand side must be equal to the same number of x's on the right-hand side. So we know that a plus b must be equal to 1. And what else can we tell? Well, we've got a minus 1 here, and we've got some numbers here. So we know that minus 1 must be equal to a minus 5b. We can say that again with certainty. So from our first equation here, I'll call this number 1, and I'll call this equation here number 2. So from equation number 1, we can say that b must be equal to 1 minus a. We can then plug this into number 2, and if we do that, we get a take away 5 times 1 minus a, plugging the b, the 1 minus a into b. So we get that a take away 5 times 1 minus a. Just expanding the brackets, we get a take away 5 plus 5a. Simplifying, we get 6a minus 5, and this is equal to the number minus 1. Now we're going to add 5 to both sides. If we do that, we get 6a equals the number 4. So a is going to be 4 divided by 6, which is the same as 2 over 3. So a is 2 over 3. And then b, well, that's 1 minus a, because we can see that from up there. So b is going to be 1 take away 2/3. That's 1/3. Okay, so now we've worked out this a and b value. So now we can actually just write down our answer in full. Let's just do this then. So our final answer, just by I'll just move everything up again. Sorry, 1 second. There we go. So our final answer for our decomposition is that x minus 1 divided by x squared minus 4x minus 5 is exactly equivalent to or identical to a, which is 2/3. So 2/3 over x minus 5. So we can see up there. So that's just the same as 2 over 3 times x minus 5. And then plus 1 over 3 times x plus 1, because again the b value is 1/3, the a value is 2/3, so we're just plugging those into this decomposition there. And again, we can actually just, I mean, if you wanted to check it, you can just like use fraction addition on the right hand side, and you'll actually get the same result as what we get here anyway. So yeah, this would work essentially. So this will give us it will give us the result that we need, and that, yeah, that is exactly how we would decompose this fraction, this x minus 1 over x squared minus 4x minus 5 fraction into partial fractions. So yeah, the key rule is this here. So when you've got a linear, well, a degree on your numerator less than the degree in your denominator, and when your denominator is a product of linear factors, so this is a linear factor because it's a linear term, and again, this is a linear factor here. When you've got a product of linear factors, you can actually split them up into 2 fractions with linear factors on the denominators and numbers, constant numbers. So a, b are constants. So you can split them up into constant numbers on your numerator, and you can do the process that we just did, multiply both sides by this denominator, set this fraction equal to this fraction, and then multiply both sides by the denominator, equate the coefficients. So that this technique here is called equating coefficients, because we're equating the x coefficients and the constant coefficients. And then from there, we can just work out, use some simultaneous equations, and we can work out the a and b values. and we can get our partial fraction decomposition. So yeah, that's our first one. In the next video, we're going to look at another partial fraction decomposition because there's actually two more that we need to learn. So this is the first one, but there's two more that we're going to go through as well.